Review number 1 is going over some stuff that we did not complete in Unit 6. So I'll do the best I can to go through explaining some of these things. Unit 6 is all about rectangles, parallelograms, rhombuses, triangles, and some volume and density. So with parallelograms, one of the things you want to understand is opposite sides and opposite angles are congruent to each other. So with opposite sides, if you're given a side that's across from the other side, you can just set those equal to each other. So for number 1, you're going to solve the equation 6x minus 20 equals 3x plus 10. That's all you got to do. To find x. So y'all know how to solve equations, but reviewing it, get all the x terms on one side. And then get the numbers on the other. And then finally divide by any coefficients out front. So that's going to give you 3. 30 divided by 3 is going to be 10. So the value of x in this case is 10. Sometimes they ask for the side length, and you could plug that in. 3 times 10 is 30, plus 10 is 40. But they just want to know what x is, so x is going to be 10. Question 2, find the values of x and y in the parallelogram below. These are angles, and in a parallelogram, opposite angles are congruent, and consecutive angles are supplementary. So you could do this one of 2 ways. You can, these two would add to 180, but I would just take the opposite angles and set them equal to each other. So I would say 2x plus 40 equals 70, and the other equation would be 5y plus 15 equals 110. So subtract the 40 from both sides, and you get 2x equals 30. Divide by 2, x equals 15. Subtract the 15 from both sides, 5y is 95. And 95 divided by 5 will be your answer for y. So we can check that. It's 19. So y is going to be 19, x is going to be 15. And that's how you get those in that problem. Segments and centers and triangles. These are tricky. There's a lot of terminology here, but I'll try to be very brief with I can. Again, we didn't learn this because we skipped Unit 6, but basically a median is a segment that connects the vertex to the opposite side of a triangle in the midpoint. So you see these two are equal. Same thing here. Those two are equal. And here, those two are equal. So turns out that that point that they intersect in is called a centroid. So medians intersect at a centroid. And that centroid has a couple properties. It's the center of balance of the triangle, but also it splits the median up into a 2-to-1 ratio. So that's going to be twice as long as that part of it here. So this is double that, and that's the case with this and that, and this and that. We'll get into that later in another problem. Angle bisectors are what they do. They bisect angles. Bisect means to cut in half. So if you have an angle bisector that cuts an angle in half, those two are equal. Those two angles are equal. And those two angles are equal. They meet at a point called an incenter. The reason it's called an incenter is because if you were to draw a circle in the triangle, that point is actually equidistant from the sides of the triangle. So basically it's the point that's the center of a circle that's drawn inside the triangle. So it's an inscribed circle, center of an inscribed circle. Same distance from all the sides. A perpendicular bisector is perpendicular means 90-degree angle. So you see right angles. They bisect the side at a 90-degree angle. This, by the way, is not drawn to scale. But that point that you see where they intersect is the center of a circle going around the triangle. So that's the circumcenter. Circumscribed is a circle going around a triangle. Perpendicular bisectors meet at circumcenters. It's equidistant from the vertices of the triangle. So the radius would be from the center there to there. So we can answer a couple questions based off of that. But basically MCAIPC, median, centroid, angle, bisector, incenter, perpendicular bisector, circumcenter. So we got a couple questions. Question 1, G is a centroid. That means these are medians. AG is 12. FB is 8. FG is 3. So a couple things about that. If we know this is a centroid, that means that those two are equal, and therefore that's going to be 8 as well. We also know that this median, this portion of the median will be twice as long as that. So if that's 3, that's going to be 6. And for this one, that portion of the median is half of that 12. So if that's 12, that's going to be 6 as well. So the question wants to know, what's the length of FC? FC is from here to there. So FC is composed of the segment FG, which is 3, and the segment GC, which is double that. So 3 times 2 is 6. So we're going to add those two together. 3 plus 6 is going to give you the total length from F to C. So take your 3, double it, add it to the 3, and you get the total length. So F to C is 9. Another question that has come up before. Joshua is constructing a triangle with a circle inscribed in it. So let's draw that. Circle inscribed in the triangle will look like that. Each vertex of the triangle will have a line passing through it bisecting the angle. So we are drawing angle bisectors. And they're going to meet at a certain point. No matter where he places the third vertex, the following conditions will be true. Each line will always bisect its corresponding vertex angle. So we already know that. Each line will bisect the angle. The 3 lines will intersect at the center of the circle, as you can see there. And the circle will always be inscribed in the triangle. What type of center exists where the 3 lines intersect? So if we look at our little table here, if these are angle bisectors, then that center of the circle is called the incenter. So knowing that these are angle bisectors right from the beginning, it's going to bisect the angle. It tells you those are angle bisectors. So angle bisectors meet at the incenter. So that point right there is called an incenter because it's the center of a circle inside that triangle. Part 3 is a bunch of volume and density formulas that we haven't gone over yet. So they are here for your reference, and some area formulas too: circle, rectangle, area of a triangle, circumference, square. But then volume of a rectangular prism, you might better know that as L times W times H, length times width times height. Volume of a cube is side to the third power, side cubed. Volume of a cylinder, pi r squared times height. Volume of a cone is 1/3 pi r squared times height. Sphere is 4/3 pi r cubed. And the density is mass over volume. So D equals mass over volume. And then you might have to use Pythagorean theorem. You never know. So A squared plus B squared equals C squared. So these are just some common formulas that do come up. I would focus on trying to know these. I wouldn't worry so much about the sphere because I doubt you'll see it, because in this problem here, they give you the formulas. So let's look at question number 1. To completely cover a spherical ball, a company uses a total of 36 square inches of material. Let's stop right there. It gives you the area, all right? Area of a sphere. What's the maximum volume of a sphere? Now we know the volume formula is up here, but it doesn't give you the area formula. But in here it says, note the surface area of a sphere is 4 pi r squared, and the volume of a sphere is 4/3 pi r cubed. So it gives you that information. So we're going to start with knowing the area. 36 is the area, and we know that it's the formula is 4 pi r squared. So we're going to set those equal, and we're going to solve. So let's divide the 4 and the pi out. And 36 divided by 4 is 9, so it's really just 9 over pi. And so r is going to be the square root of whatever 9 over pi is. So let's do that. SQRT 9 divided by pi. So that radius is approximately 1.6925. You can keep going if you need to for more accuracy. But now that we have our radius, we can go ahead and plug that into the volume formula. So it says, what's the maximum volume of the ball? So the volume is going to be 4/3 pi times that 1.6925 to the 3rd power. And as a decimal, that's going to give you, let's see, 4 divided by 3 pi, 1.69. I would go out at least 4 spots. I mean, you can go out as far as you want. Raised to the 3rd power. And so that volume ends up being about 20.31. And if you cut off some of these numbers, it's okay. It'll be close enough. Like if you do 1.69, you still get 20.2, which is effectively what we're looking for anyway. But over here, one of those is going to give you that same decimal. So at that point, it's a matter of checking the decimals. 27 pi is way too big. That's 84.8. 36 divided by the square root of pi. That's the same thing, right? So 36 divided by the square root of pi will be your answer. Question 2 is a continuation of that same part 3. So a storage container is a cylinder with a height of 32.5 centimeters and a radius of 6 centimeters. So we have our height. Our radius is 6. We want to know how many liters of water will the storage container hold. So the liters conversion is here, but let's first find the centimeters cubed. So we're going to go to a cylinder. It's pi r squared times the height. And we're going to plug that in. So pi times 6 squared, excuse me, not 32, times 32.5. So our volume in terms of cubic centimeters will be whatever that becomes. So let's test that out. That volume is 3675.66 centimeters cubed. And this question gives you a conversion. They want to know the liters. So we'll have to divide out that 1,000 centimeters cubed to get that conversion. So that's actually going to be, when you divide by multiples of 10, just move the decimal over, left as many zeros as you see. So it's going to be 3.67566 liters. So move that decimal over. And of course, that'll round to 3.68. And you can always test the division if you want. And there you go, 3.67566, 3.68. Question 3 and 4 are similar. 3 is the length of a rectangular prism is 4 square to 3 units. The height is 3 square to 6 units. If the volume is irrational, what could be the measure of the width of the rectangular prism? So the volume of a rectangular prism is length times width times height. So if we're given the length 4 square root of 3, and we're given the height, we don't know the width, but it doesn't matter what order we multiply them. So we'll put the 3 square root of 6 next to it. We want to know what is the width that's going to give you a volume that's irrational. And irrational numbers are numbers that can't be made as fractions. So what we're looking for is, do we have a number that's a repeating decimal? Or not a repeating decimal, like a random string of decimals with no pattern. That's what we're looking for. So we have to test it with our answer choices. So F4 SQRT3, right arrow, and then 3 SQRT6. You can put a times between them if you want. And then times, let's say 2 square root of 50. Now, if you look at that, if you plug in there, that volume's going to give you 720. That's rational. So if you go through and you test all the rest of them, so 4 square root of 12, that's 176.36, so on and so on. That's irrational. That's your answer. And just for good measure, you can check the other ones too. That's going to give you, oops, I forgot the 4 in there. No wonder it's different. So that's 705.45. Still irrational, but 5 square root of 8 is actually going to be 720, same as A, that's rational. And then 7 square root of 18, let's see what that is. Which is a big number, 2646, but ultimately that is rational. So the only one that's irrational is B. Or you would do the same thing. So you would do 7 square root of 2 times 3 square root of 5. And we want to test one of these heights to figure out which one's going to give you an irrational. So you can try that on your own, pause it, and see if you get the right answer. If you go through and test them all out, if you look at the calculator, you'll get these 3 numbers give you nice even whole numbers. Those are rational. And then the last one is going to be the oddball, 296.9848, etc. So it's going to be D. All right, so the last part here, talking about farmer in the land. Farmer wants to buy between 90 and 100 acres of land. He wants a rectangular piece of land that is 1,500 yards long and 300 yards wide. I'm going to model this on a separate sheet of paper. So we've got a rectangular piece of land that is 1,500 yards long and 300 yards wide. The piece of land is being sold as one complete unit for $87,000. So the cost is $87,000. If the farmer does not want to spend more than $900 an acre, so the requirements We want it to be less than $900 an acre. There's also another requirement at the beginning. It's got to be between 90 and 100 acres. So my approach is, first, I want to figure out how big this is, how many acres this is, so we can see if we get in that requirement here. So my yards, there are 3 feet in 1 yard. My markers are all dying. So 3 feet equals 1 yard, which means we have to actually convert this to feet. So we know there's 3 feet in a yard. 300 times 3 is 900 feet. So that's going to be 900. And then 15 times 3 is 45. So that's going to be 4,500 feet. So let's look at our area. So our total area is going to be, as a rectangle, it's length times width. So it's going to be 4,500 times 900. It's going to be pretty big. And that's your unit in feet squared. Now this problem asks, it does give you a conversion. It says 1 acre is 43,560 feet squared. So we're going to divide that by 43,560 to get the acres. And we get that acre is 92.975 acres. So you can measure area in acres, and that's what that one would be. So we're almost at a point where we can answer the question. So let's look here, look at your acres. Is it between 90 and 100 acres? Yes. Is it going to be less than $900 an acre? Well, we can, the most he's willing to spend is 900. So if we times this by 900, that'll be the max he's willing to spend on that. So let's do that. So he's willing to spend $83,677 at the most. Okay, that's if he spends $900 an acre. Now the cost, he wants to spend less than $900 an acre. The overall cost is $87,000. Most he's willing to spend on this plot of land would be $83,677. So it costs too much. So the price is too much. The land's right. Let's answer the question. Yes, the amount of land satisfies his needs and the price is low enough. Not true. No, the price is low enough, but there is too much land. That's the opposite. No, the price is low enough, but there's not enough land. No, we have enough land, but the amount of land satisfies what he needs, but the price is too high. All right, let's talk about cross sections and rotations real quick. Okay, I have these all worked out. So basically a cross section, and when you slice a 3-dimensional figure, is the 2-dimensional shape you get when you see it. So if you take a rectangular prism and you slice it along the horizontal, you're going to get a rectangle when you look at it. And same way if you go vertical, perpendicular. With a cube, since all the sides are the same, you're going to get a square for both of those. With a cylinder, you'll see a circle if you go parallel, but you're actually going to make a rectangle if you slice a cylinder vertically. With a cone, you'll see a circle, and then you'll get a triangle if you go from the top through to the bottom. A sphere, you'll get a circle no matter where you go. And with a pyramid, you get a square on the base if you go parallel to it, and you can make a triangle going perpendicular to it. When you take these two-dimensional shapes and rotate them, a rectangle can rotate around the center of it to get a cylinder. A cone can rotate around, a triangle can rotate to get a cone, and a circle can rotate to get a sphere. All right, last section, part 5. Equation of a circle. Remember the opposite sign for the circle equations when you're graphing them. And let's go over and do these. Center with circle at the origin with a radius of 9. Radius of 9, and it's going to be shifted 4 to the right and 5 down. So that center will be 4, -5. The radius is 9. So remember at the end, you square the radius. So that's going to be 9 squared. So what you're going to do is you're going to say 4, or x minus 4 squared plus y plus 5 squared equals 9 squared. Always square the radius. So 9 squared is 81. Remember, these are opposite of the center. So it's going to be x minus 4 squared plus y plus 5 squared equals 81. On Desmos, you can graph circles. So we'll go ahead and graph what we have here so you can verify that. And if you, let me zoom that out a little bit. So you can see that center is 4, -5, and it does go out what appears to be 9 units. So if you go over to 13 from 4, that is 9 units. All right, question number 2. Which in this equation of a circle is a center, -3, 2, passes through the point 4, 3. So we can get knowing the center, we do x plus 3 squared plus y minus 2 squared, but we don't know the radius. So we'll leave a big old question mark. Now what I like to do is I like to plug in the x and y values that I'm given. So I'm going to plug in 4 here and 3 there. So it's going to be 4, 3. Now I'm going to figure out what that number at the end of the equation should be. You get 50, right? So that end number, that r squared is 50. That's what we're looking for here. So that means x plus 3 squared plus y minus 2 squared is equal to 50. Oops. There you go. Question 3, state the center and radius of the circle. This is in general form. We have to use completing the square by hand. We'll verify the answer first, and I'll go back and show you how to do it by hand. So x squared plus y squared plus 8x minus 6y minus 11 equals 0. And I'll zoom in on that. You can probably make out what the center is. If you go left 4 and up 3, that's going to be your center. -4, 3. And if you look at how much it goes out, it goes 1, 2, 3, 4, 5, 6 units out. So your radius is 6. So -4, 3, radius is 6. Let me show you how to get that by hand. So what you do is you complete the square. You do x squared plus 8x, leave a blank. You do plus y squared minus 6y, leave a blank. Move this 11 over here, so it equals positive 11. And then you're going to add 2 blanks to that. You're going to complete the square by taking the number in front of x, dividing by 2, and squaring it. 4 squared is 16. We add it to both sides. You do the same thing with the y. 6 divided by 2 squared. 3 squared is 9. It's always going to be positive. So even if that's negative, a negative squared is positive. So we're going to add 9 there. And we're going to factor it. So x plus 4 times x plus 4. X plus 4 times x plus 4 is x squared plus 8x plus 16. Y minus 3 times y minus 3. And then these numbers add to 11 plus 16 is 27 plus 9, 36. You can verify all that in the calculator, but look at your center, negative 4, 3. And your radius is the square root of 36, which is 6. And then number 4, you're going to basically do the same thing. X squared plus y squared plus 12y minus 8x equals 10. Let's rearrange. X squared minus 8x. Y squared plus 12y. And the 10's already over here, so we'll just say 10. Completing the square, 8 divided by 2 squared. That's 4 squared is 16. We'll put that there. 12 divided by 2 squared. 6 squared is 36. Put that there. And then factor it out. So it's going to be x minus 4. X minus 4. So x minus 4 squared. Y plus 6. Y plus 6. Y plus 6 squared. And then these numbers, 26 plus 36 is 56. Should be 62. But we just want to know the center. So the center is going to be the opposite of these numbers. So it's going to be positive 4 and negative 6. And you can really kind of just take this 8 divided by 2 and flip the sign. Same with the 12 to get that center. Or you could graph it. All right, this concludes review number 1.